Hello everyone, good evening. I think I'm audible, right? Okay. This is lecture number 3 of analytical geometry. So in this class, we're going to continue direction, cosine and direction ratios. And this is the last video on direction, cosine and direction ratio, right? So far we have seen, if you haven't seen the last two videos, go through that and come back to this video, right? Yes. So as of now, what we have seen in DC and DR is, so in the very first video, we introduced what is meant by DC. And then we have seen some note that is based on DCs, and we have introduced a definition of direction ratios, and then we have solved many problems, right? And then we introduced angle between the two lines in terms of DC, in terms of DR, and then we have solved many problems, right? Super. So we will start ninth problem. So in this class, overall, we're going to do 7 problems. That's it, right? That is in DC and DR. I'm planning to do 15 problems overall. This is ninth problem. So in this class, we will be completing 7 problems. So overall, 15 problems will be completed on 15 problems will be on DC and DR, right? So again, these 7 problems are very, very important, right? In the last class, we have solved 4 problems that is based on perpendicular and parallel. So these are slightly different from that, right? So we'll be solving 7 problems and then we'll winding off direction, cosine and direction ratio. And in next class, we'll be starting planes. Okay. So we will start solving all 7 problems. So we will do this fast. So I'll try to complete this within 2 hours. Right? Okay. If the edges of a rectangular parallelepiped be A comma B comma C, right? So we have a rectangular parallelepiped whose edges are A comma B comma C. Show that the angle between the 4 diagonals are given by cos inverse of plus or minus a square plus or minus b square plus or minus c square divided by a square plus b square plus c square. There is no issue in video, right? Okay. So we'll do this, right? So very easy problem again. So we have a rectangular parallelepiped whose edges are a comma b comma c. Show that the angle between the 4 diagonals is given by that. Right? Again, very easy. So first we'll draw a rectangular parallelepiped. Right? So we have a rectangular parallelepiped. So we have a rectangle parallelepiped. Let's extend this and mark this as axis. Right. So let us mark this as A. Let us mark this as B. Let us mark this as C. Right. So we have our x-axis, y-axis is our b-axis, and z-axis is our c-axis. Z-axis is our c-axis. Right. Okay. So let A comma B comma C be the coterminal. Be the coterminal edges. Let OA, OB, OC be the coordinate axis. Be the coordinate axis, right? So again, this OA, OB, OC is our coordinate axis, right? So let the distance from O to A be A. Let this distance be B. Let this distance be C, right? So let us make OA, that is the distance of O to A, be A, and distance from O to B, B, and O to C, B, C, right? Now we will mark the vertices in this cube. So this point will be A comma 0 comma 0, right? This point will be 0 comma B comma 0, and this point will be 0 comma 0 comma C, right? Let's call this point to be D, call this point to be E, call this point to be F, and this point to be G, right? Now, what will be the vertices of D? So this is our y-axis, this is our x-axis, this is our z-axis, right? You can also rename this to be y and z to be z. Now, we are in A, we are moving in y-axis. So that means we are moving b units in y-axis. So already a comma 0 comma 0. This point will be a comma b comma 0. Right? So you can see from here to here we are moving in y-axis and we know this distance is b. So therefore, so from here to here we are moving b units in y-axis. So x and z will remain same. Now, what about the point E? So we are in a comma 0 comma 0. So we are moving in z axis. So z axis we are moving c units. So x y will remain same. Z axis we are moving c units. So that point will be a comma 0 comma c. And what about the point G? We are in G 0 comma b comma 0. So we are moving in z axis c units. So this point will be 0 comma b comma c. And what about the point F? So we are in a comma b comma c, and we are moving in z axis c units. So already it is a b. Z axis we are moving from c units. This point will be a comma b comma c. Right. So remember how to plot the vertices of this rectangular parallelepiped. Now, if the edges of the rectangular parallelepiped be a comma b comma c, show that the angle between four diagonals. See, there are four body diagonals in cube, 12 face diagonals and four body diagonals. So always take four body diagonals, right? So what are those four body diagonals? So we will write, let diagonals be. So there are four body diagonals. The first diagonal is OF, right? OF is our first diagonal, right? OF is our first diagonal. So OF is our first diagonal, and BE is our second diagonal, right? OF is our first diagonal, and BE is our second diagonal, B to E, right? So OF, BE, and then we will have CD to be the third diagonal, and AG to be the fourth diagonal. So you will have four diagonals in the cube. So let body diagonals, let the diagonals be OF, OF, and then BE, and then AGCD, AGCD, right? So these are the four diagonals OF, BE, AGCD. Remember this, right? Remember this OF, BE. So just start with what OF, BE, and then from here to here you need to connect these two. So CD, GA or AG. So these are the four body diagonals. Now we need to show that the angle between the four diagonals, very simple. So we need to show angle between OF and BE is that OF of angle. There are four diagonals. So how to find angle between them? So we can have six possible cases. Yes or no? We can find angle between this and this, this and this, this and this. So we have 1, 2, 3. We can find angle between this and this. So we have 4. We can find angle between this and this, and we can find angle between this and this. See, very simple. How many two element subset you can form with four elements? How many two element subset you can form with four elements? It is nothing but 4C2. So 4C2 is 6. So you will have six possible cases, right? You need to find angle between all those six possible cases, and you need to show that all these six angles are of this type only. It can be plus or it can be minus here, right? So first what we will do is we will find angle between, first we will find angle between OF and BE, right? We need to find angle between OF and BE. Similarly, we need to find angle between BE and AG, AG and CD, CD and OF, OF and AG, BE and CD. We need to find six angles, and all these six angles are of this type only. It can be plus or minus, plus or minus, plus or minus. It can be plus or it can be minus. Okay, so first we will find angle between OF and BE. Now, what we will do is you find the direction cosine of OF, find direction cosine of BE. then you can easily find angle between them, right? Now what is OF? What is direction cosine of OF? What is direction cosine of OF? Now what is direction cosine of line joining two point? We know, right? X2 minus x1 divided by length of that, y2 minus y1 divided by length of that, z2 minus z1 divided by length of that. So direction cosine of OF. So O is 0 comma 0 comma 0, F is A comma B comma C, right? So therefore direction cosine of OF will be x2 minus x1 divided by length of OF, comma y2 minus y1 divided by length of OF, z2 minus z1 divided by length of OF. So therefore A divided by, now what is length of this? So it is root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. So we have a square plus b square plus c square will be the length. The direction cosine of line joining two points we already know, right? If A is x1 y1 z1, B is x2 y2 z2, direction cosine of line joining two points is x2 minus x1 by length of AB, y2 minus y1 by length of AB, z2 minus z1 divided by length of AB. This is the direction cosine of OF. Now similarly, you find direction cosine of BE, right? Now direction cosine of BE. Now what is B? B is 0 comma B comma 0, and E. What is E? E is A comma 0 comma C. A comma 0 comma C. So the direction cosine will be x2 minus x1 divided by length of AB. So x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. Again you will have a square plus b square plus c square. This will be minus b, right? 0 minus b divided by root of a square plus b square plus c square, z2 minus z1 divided by root of a square plus b square plus c square. So here we have a and here we have minus b. That is the only difference. Now, so therefore angle between OF and BE. So we know direction cosine of OF and we know direction cosine of BE also. This is our L1 M1 N1. This is our L2 M2 N2. So you know angle between two lines, right? So it is cos theta is equal to L1 L2. So A into, it is A by root of a square plus b square plus c square into again a divided by root of a square plus b square plus c square plus m1 m2. So m1 is b divided by root of a square plus b square plus c square. M2 is minus b divided by root of a square plus b square plus c square plus n1 n2. So it will be c divided by root of a square plus b square plus c square into c divided by root of a square plus b square plus c square. Now make a dot product. So this will be a square minus b square plus c square divided by a square plus b square plus c square. Therefore cos theta is equal to cos inverse of a square minus b square plus c square divided by a square plus b square plus c square. This is the angle between one of the two of the diagonals. Now similarly you need to prove for all these. You can see it is of that form, right? So here a square is positive, b square is negative in this case, but either this will be plus or minus, it will be plus or it can be minus. In this case it is plus, here it is minus, here it is plus. Similarly you need to prove for, you need to find angle between B and AG and CD. So you need to find all six angles. All six angles will be of this form only. I'm not going to do that, right? Take this exercise. So angle, I have found angle between OF and BE. Now similarly find angle between BE and AG, right? Similarly find angle between BE AG. right? BEAG, AGCD, AGCD, CD and OF, OFAG, OFAG, and OFAG, PECD. So you need to find all this. So it will be of this type only, right? Either this will be plus or minus. That three thing will only be changed. That three thing will only be changed. Everything is clear, right? Audio and video. See, there are four diagonals in cube, right? Remember this OFBE, four body diagonals, OFBE, AG, and CD. After this, very easy. You just have to find angle between them. So find direction cosine of OF, direction cosine of BE. So you know direction cosine of line joining 2 points. So make use of that, make use of that. And then you apply angle between these two lines formula. You'll be getting this answer. Very easy. These are very simple problems. And find BE and AG. Find direction cosine of BE. Now what is direction cosine of BE? So B is this, E is this. So it will be A minus B and C, right? Because A minus 0, 0 minus B. So it will be A by root of A square plus B square plus C square minus B divided by root of A square plus B square plus C square. C divided by root of A square plus B square plus C square is the direction cosine of BE. Now find direction cosine of AG. So A is this, C is this. So 0 minus A. So minus A divided by root of A square plus B square plus C square and so on, right? Okay, AG. So A is here, G is here. Similarly, find direction cosine of this line joining 2 points. You can get the answer, right? I think you can do this, right? Very easy problem. Can you move on to next problem? See, 13 are watching. If you can say something, miss, then only I can move. You have to find angle between 6 lines. I have found angle between one of the line, one of the angle between one of them, which is OF and BE. Similarly, you have to find angle between BEAG, AGCD, CDOF, OFAG, and BECD, right? Similarly, find angle between them, you will get in this pattern. Okay. Remember the formula remember the formula direction cosine of line joining 2 points. X2 minus x1 divided by length of this, y2 minus y1 divided by length of this, z2 minus z1 divided by length of. Okay. Okay. So we move on to 10th problem. So a line makes an angle alpha, beta, gamma. This is an IFOS question. Uh, Actually, there are 4 IFOS questions I have said in the beginning. We have solved 3 already, right? In the very first class, we have solved one problem. And in the last class, we have solved 2 IFOS questions. That is the parallel and perpendicular conditions. Now, this is the fourth question and last question in IFOS PYQ. The line makes an angle alpha, beta, gamma with the 4 diagonals of a cube. So here we have a cube. Prove that cos square alpha plus cos square beta plus cos square gamma plus cos square delta is equal to 4 by 3. So same as previous problem, here instead of rectangular parallelepiped, we have a cube, right? Instead of rectangular parallelepiped, we have a cube. See, final answer, we have to prove this only. See, this is very simplest problem. We have to prove angle is of this type. We need to prove that angle between any two diagonal will be in this form. I have found angle between these two, and I have shown it is in this form only. You can see it is in this form only. Only thing is here we have plus, here we have minus, here we have plus. It can be plus or minus, plus or minus, plus or minus. Similarly, if you find angle between all the 6 lines, you will get in this pattern only. Either it is plus or minus, plus or minus, plus or minus you will have. Okay. So only difference here is we have a cube instead of rectangular parallelepiped. A line makes an angle alpha, beta, gamma. Okay, very easy problem, very important problem. So we have a cube. So cube means we have to draw squares. Right? So let A comma B comma C be the edges, co-terminal edges. So let A comma B comma C be the co-terminal edges. So since it is a cube, there we have A, B and C. Here we have every sides to be equal only because it is a cube. So we have A only. Right? So let's call this to be A, call this to be A, call this to be A because it is cube. All sides are equal in cube, right? So instead of ABC, here we have A. The previous one was rectangular parallelepiped, but here we have a cube. So let A comma, so let A comma B comma C be edges and OA, OB, OCB coordinate axis. OA, OB, OCB coordinate axis. Now let us take the distance OA to be A, and since it is a cube, all will be equal to A only. Right? So what about this point? This point is A comma, this point is A comma 0 comma 0, and here we are moving Z A units in Z axis. So 0 comma 0 comma A, this is origin, and 0 comma A comma 0, right? A units in Y axis. All are A units only. So what about this point? This is our D, this is our E, this is our F, this is our G. Now D. So we are in A. We are moving Y units. This will be A comma 0. Here we are in X. We are moving Z A units in Z axis. So A comma 0 comma A. This point will be A comma A comma A. Right? Already we are in A comma 0. We are moving A units in Z axis. So A comma A comma A. So already we are in 0 comma A comma 0. So we are moving Z units. A units in Z axis. So 0 comma A comma A. So instead of ABC, here we have A. All sides are. Now again you can see a line makes an angle alpha, beta, gamma with four diagonals of a cube. So first what we will do is we will find we will find the what are the four diagonals here? Again same, right? The four diagonals are OF BE, OF BE, AG CD, AG CD, right? Now we have a line. Okay, so first what we will do is we will find direction cosine of OF, direction cosine of BE, direction cosine of AG and CD, right? At first I'll find it down, then I'll explain more. Now what is direction cosine of OF? So O is origin, so 0 comma 0 comma 0, and the F is A comma A comma A. Now what is direction cosine? X2 minus X1 divided by length of this. So it will be A square plus A square plus A square, y2 minus y1 divided by length of this, A square plus A square plus A square, z2 minus z1 divided by length of this. So we have A divided by root of 3A square, A divided by root of 3A square, A divided by root of 3A square. This is same as this A will get cancelled if I take A square outside. So we have this to be equal to 1 by root 3, 1 by root 3, 1 by root 3. This is the direction cosine of OF, right? Now we will find direction cosine of BE, AG and CD. So direction cosine of BE. BE. So B is 0 comma B comma 0. and E is A comma 0 comma A comma 0 comma. So what is direction cosine? Sorry, it is 0 comma A comma. So what is direction cosine? A divided by root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. A square plus A square plus A square minus A divided by root of A square plus A square plus A square, z2 minus z1 divided by root of A square plus A square plus A square. So direction cosine is 1 by root 3 minus 1 by root 3 and 1 by root 3. This is the direction cosine of B. Right? Just take A square outside, A will get cancelled. Okay. Now, similarly, you find direction cosine of what is next? AG and CD. So AG. So A is A comma 0 comma 0. G is 0 comma A comma A. So this direction cosine will be 0 minus A. So you will have minus 1 by root 3, 1 by root 3, and 1 by root 3. This will be the direction cosine of this, right? 0 minus A by root of again 3A square, A minus 0 by root of again 3A square, A minus 0 divided by root of 3A square. And what about the direction cosine of AG and CD? So C is 0 comma 0 comma A and D is A comma A comma 0. This direction cosine will be A minus. So we will have 1 by root 3, 1 by root 3 minus 1 by root 3. This is the direction cosine, right? So as of now, we have found direction cosine of all these four lines. Now, what they are saying is we have another line. We have another line that makes an angle alpha, beta, gamma, delta with these four lines. So already we have these four lines. So what are those four lines? So we have OF is one line, BE is another line, CD is one line, AG is another line. So already we have four lines. So we have one more line. We have one more line which makes an angle. So we have a one more line here, and this line makes an angle alpha with the first line. Let us call this as L. Right? This L makes an angle alpha with the first line. First line is OF. This makes an angle alpha. And similarly, it makes an angle beta with the second line. Second line is BE. So this makes an angle beta, the second line. And similarly, this line makes an angle gamma with the third line, is AG. Makes an angle gamma with the third line and delta with fourth line, right? So let L be the line. Let L be the line that makes an angle alpha, beta, gamma, delta with four diagonals. Right? So we have a line that makes an angle alpha, beta, gamma, delta. So let this line, let the direction cosine of the line be L comma M comma N. Right? Let us assume that this line has direction cosine L comma M comma N. Right? Now we will find angle between this L and four diagonals. Now what is angle this makes an angle alpha with the first diagonal. So we will find L with OF makes an angle alpha. L with BE makes an angle beta. L with AG makes an angle gamma. L with CD makes an angle delta. Because this line makes an angle alpha, beta, gamma with these four diagonals. So let alpha be the angle between L and OF. Let alpha be the angle between L and OF. right? So you know direction cosine of this, you know direction cosine of this. What is the direction cosine of, what is direction cosine of L? It is L comma M comma N. Now what is direction cosine of OF? Is 1 by root 3, 1 by root 3, 1 by root 3. Now what is the angle between the two lines? If you know, if you know direction cosine, so cos alpha, because alpha is the angle between the two lines, and you know DC is also. So L1 L2 plus M1 N2 plus N1 N2. So we will have L by root 3 plus M by root 3 plus N by root 3. This is the value of cos alpha. Similarly, let beta be the angle between, let beta be the angle between L and second diagonal OF BE, right? BE. Now again, what is the direction cosine of L? Direction cosine of L is L comma M comma N, and direction cosine of BE is 1 by root 3 minus 1 by root 3, 1 by root 3. So beta is the angle. So we have cos beta is equal to L1 L2 plus M1 M2 plus N1 N2. This is the value of cos beta. Now similarly, let gamma and delta be the angle between L and L and. Now similarly, let gamma be the angle between L and AG and L and CD. Delta be the angle between L and CD. So we have this, this minus 1 by root 3. So L into this will be, so minus L by root 3. So this answer will be cos gamma will be minus L by root 3 plus M by root 3 plus N by root 3. And similarly, you find angle between these two, DC of DC, multiply this. So DC of CD is this. So that is L comma M comma N. So multiply here. So you will have minus N by root 3. So we have found cos alpha, cos beta, cos gamma, cos delta. Now we need to square it up and add it. We need to prove that it is equal to 4 by 3. So cos square alpha plus cos square beta plus cos square gamma plus cos square delta is 4 by 3. So cos square alpha, cos square beta, cos square gamma plus cos square delta. So we need to add it up and we need to show that it is equal to 4 by 3. So add this. So one I can, if I square it up, I can take 1 by 3 outside. So 1 by 3 L plus M plus N whole square and cos square beta. So I can take 1 by root 3 outside, and if I square it up, you will have L minus M plus N whole square. L minus 1 by 3 L minus M plus N whole square, and here you will have minus L plus M plus N whole square 1 by 3 L plus M minus N whole square, right? I'm just squaring up and adding. Squaring this 1 by 3 I can take outside. L plus L plus M plus N whole square 1 by 3 take outside. L minus M plus N whole square. Squaring and I'm taking outside. So minus L plus M, yes. So again you know A plus B plus C whole square formula. A square plus B square plus C square plus 2AB plus 2BC plus 2CA. So we'll apply that. So A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Right? I can take 1 by 3 outside. And again A square Here we can see A is L, B is minus M. So A square plus B square plus C square 2AB. So it will be minus 2LM minus 2MN plus 2 times LN. Right? I'm just applying A plus B plus C whole square formula. So which is A square plus B square plus C square plus 2AB plus 2BC plus 2CA. But here B is minus M. So 2AB will be A is L, B is minus M. So 2AB will be minus 2LM. BC will be minus 2MN and that will be LN. So plus again A square plus B square plus C square. 2 times AB will be minus 2 times LM plus 2 times MN minus 2 times Ln. And again A square plus B square plus C square. 2AB plus 2BC plus 2CA. So this is what you will have, right? Now L square plus M square plus all these will be 1. All these will be 1, right? So 1, 1, 1, 1. So we will have 4. These will be cancelled, right? Minus 2LM plus 2LM minus 2LM plus 2LM 2MN minus 2MN 2MN minus 2MN 2NL minus 2NL 2NL minus 2NL. So all these will get cancelled. This is 1, this is 1, this is 1, this is 1. So we will have 1 by 3 of 1 plus 1 plus 1 plus 1. So this is equal to 4 by 3. This is what we need to do. Right? So cos square alpha plus cos square beta plus cos square gamma plus cos square delta is 4 by 3. Very important problem and very easy problem also. So just find direction cosine of 4 diagonals. And then let us assume this has direction cosine L comma M comma N. Now alpha beta, this line makes an angle alpha beta gamma delta with those 4 diagonals. Cos alpha, find cos alpha, cos beta, cos gamma, cos delta, square it up, you will get 4 by 3 as the answer. So we'll move on to the next problem. If L1, M1, N1, L2, M2, N2, L3, M3, N3 be the direction cosine of 3 mutually perpendicular lines, then find direction cosine of a line whose direction cosines are proportional to L1, L1 plus L2 plus L3, M1 plus M2 plus N3, N1 plus N2 plus N3, and prove that this line is equally inclined to the given lines. So we have 3 mutually perpendicular lines. Mutually perpendicular means angle between all 3 is 90 degree. So we have 3 mutually perpendicular lines. So this line has direction cosine L1, M1, N1, and this has direction cosine L2, M2, N2, and this has direction cosine L3, M3, and N3. Then find the direction cosine of a line. So we need to find the direction cosine of one more line, and this direction cosine is proportional to these 3. That means what? This direction cosine is proportional to this. Then what can you say about this? This is the direction ratio, right? This is a direction ratio. So we need to find direction cosine from direction ratio. Very easy problem. So let L be the required line, right? So then find the direction cosine of a line. Let this line be L. Find the direction cosine of a line whose direction cosine is proportional to. So let L be the required line. Let L be the required line. Now they have given direction ratio of L. Yes or no? They have given direction ratio of L because that is proportional to that, right? So L1 plus L2 plus L3 divided by M1 plus M2 plus M3 divided by N1 plus N2 plus N3. So you know direction ratio, you define direction cosine. Very easy. Let us assume this to be some a comma b comma c. So instead of this long, I'm just assuming this to be a comma b comma c, right? Now what is direction cosine? How you find direction cosine from direction ratio? So it is a divided by root of a square plus b square plus c square, b divided by root of a square plus b square plus c square, c divided by root of a square plus b square plus c square. This is a direction ratio, but here instead of ABC, A is this, B is this, C is this. Now we will find this. Now we will find the value of A square plus B square plus C square. After that, we will substitute here. Remember, these three are mutually perpendicular. These three lines. Let us call this as L1, call this as L2, call this as L3. That means what? This angle is 90, this angle is 90, this angle is 90. All three are mutually perpendicular. Then what can you say about L1, L2 plus M1, N2 plus N1, N2? It is 0. What can you say about L1, L3 plus M1, M3 plus N1, N3? It is 0. Because theta is 90 degree here. So all three are mutually perpendicular only. Now we will find the value of a square plus b square plus c square. Now what is a square plus b square plus c square? So a is L1 plus M1 plus, sorry, L1 plus L2 plus L3. So L1 plus L2 plus L3 whole square. B is M1 plus M2 plus M3 whole square. C is N1 plus N2 plus N3 whole square. This is our L, M and N. Again, so this is L1 square plus L2 square plus L3 square plus 2 times L1 L2 plus 2 times L2 L3 plus 2 times L1 L3, and this will be M1 square plus M2 square plus M3 square, 2 times M1 M2, 2 times M2 M3, 2 times M1 M3 plus N1 square, N2 square, N3 square, 2 times N1 N2, 2 times N2 N3, 2 times N1 N3, right? Now if I add this vertically, this will be 1, this will be 1, this will be 1. Because L1 M1 N1, L2 M2 N2, L3 M3 are direction cosine. And again, if I take 2 common here, we will have L1 L2 plus M1 N2 plus N1 N2, which is 0. L1 L2 plus M1 M2 plus N1 N2 is 0 because they are mutually perpendicular. That means these two lines are perpendicular means what is the condition? L1 L2 plus M1 M2 plus N1 N2 is 0. So we will have, so if I add it up, so 1 plus 1 plus 1, 1 plus 1 plus 1. So if I take 2 outside, we will have L1 L2 plus M1 M2 plus N1 N2. And again if I take 2 outside here, we will have L2 L3 M2 M3 plus N2 N3. And again if I take 2 outside here, we will have L1 L3 M1 M3 plus N1 N3. This is 0, this is 0, this is 0. So we will have this to be 3 plus 0 plus 0 plus 0. This will be 3 because all these are 0. All these are 0. They are mutually perpendicular. They are mutually perpendicular. So therefore, the value of a square plus b square plus c square is this. Therefore, what about direction cosine? Direction cosine is a divided by this. So a is L1 plus L2 plus L3 divided by root of 3 because a square plus b square plus c square is 3. So root 3. B divided by this. So b is M1 plus M2, M1 plus M2 plus M3 divided by root 3, N1 plus N2 plus N3 divided by root 3. This is the direction cosine of the line. right? So this is the direction cosine of this line. Now we need to show, so we have found the direction cosine of a line whose direction cosine are proportional to this. Now prove that this line is equally inclined to given lines. Very easy. So you need to prove angle between this and this, angle between this and this, angle between this and this. We need to show all these angles are equally inclined, right? So angle between L and L1, L and L2, L and L3. So all has to be same. All has to be same. So we need to find angle between them. So what is not clear here? This is nothing big. So we need, they have given that, if you have watched the previous two videos, this is nothing to follow. So they have given, we need to find the direction cosine of a line. This is proportional to that. That means this is a direction ratio. So if you know direction ratio, how do you find direction cosine? You need to normalize that. So this divided by magnitude of a square plus b square plus c square. This divided by magnitude of a square plus b square plus c square. This divided by root of a square plus b square plus c square. So instead of ABC, we have a to be L1 plus L2 plus L3, B to be this, C to be this. This is a general formula. Instead of ABC, we have this. Substitute back here. So instead of A, we have L1 plus L2 plus L3, B this, C is this. Now root of A square plus B square plus C square turns out to be 3. So we have root 3, root 3, root 3. Okay. Now we need to show that this line is equally inclined with all three lines. Now find angle between L and L1, angle between L and L2, angle between L and L3. You show that all three angles are same. Now find, we need to show angle between, now we need to show angle between L and L1 is same as angle between L and L2, and that is same as angle between L and L3. So find angle between L and L1. So first you do this. So angle between L and L1. So what is direction cosine of L? Just now we have found, right? It is L1 plus L2 plus L3 divided by root 3, M1 plus M2 plus M3 divided by root 3, N1 plus N2 plus N3 divided by root 3. Now again, what is direction cosine of L1? So it is L1, M1, N1. Now find angle between these two. So cos theta is equal to L1 into L1 plus L2 plus L3 divided by root 3, M1, L1, L2, M1, M2, N1, N2, M1 plus M2 plus M3 divided by root 3, N1 into N1 plus N2 plus N3 by root 3, right? Now again, let us take this 1 by root 3 outside. So L1 square plus M1 square plus L1 square. Take that take that as one term, right? L1 square, M1 square, N1 square. You will have L1, L2, L1, L2 plus M1, M2 plus N1, N2. Take this as one term. L1, L3 plus M1, M3 plus N1, N3. Take this as next three terms. This will be 0. This will be 0 because they are mutually perpendicular. So this is nothing but direction cosine of two lines, that is L1 and L2. Sorry, this is angle between L1 and L2. This is angle between L1 and L3. So and we know they are mutually perpendicular. So cos 90. So it will be 0. So this is again 1. So we have cos theta is equal to 1 by root 3. So theta is equal to cos inverse of 1 by root 3. Right? Similarly, you find angle between this and this and this, you will get all to be equal to cos inverse of 1 by root 3. You will get all the terms to be equal to cos inverse of 1 by root 3. All this will be equal to cos inverse of 1 by root. This is what we need to prove, right? I have found only one. I have found only angle between L and L1. Similarly, find L1, L2. Very easy. Here we have L2, M2, N2. Instead of here we have L2, M2, N2. So L2, M2, N2. L2 square, M2 square, N2 square. That will be 1. Other terms will be 0. Right? So we will have again 1 by root 3. 1 by root 3 only. So is these three problems are clear? They are equally inclined means angle is same that from that line to other three lines. So still 4 more problems left. We'll move on to fourth problem of today's class, that is 12th problem. Okay, so we'll do this. If two pairs of opposite edges of a tetrahedron are perpendicular, then prove that third pair is also perpendicular. So next three problems are based on tetrahedron. The first two problems are based on the rectangular parallelepiped and cube. Here the next three problems are based on parallelopiped. Okay, so sorry, tetrahedron. So if two pairs of opposite edges of a tetrahedron are perpendicular, then prove that third pair is also perpendicular. So we have a tetrahedron. We have a tetrahedron, right? Let us call this as A, B, and C. Let this point be x1, y1, z1, x2, y2, z2, x3, y3, and z3, right? So this is our origin. So there will be three pairs. Okay, if two pairs of opposite edges of a tetrahedron are perpendicular, so two pairs of opposite edges are perpendicular. So you can see one pair is OA and BC. They are given that two pairs are perpendicular. So one pair is, they are given two pairs of opposite edges are perpendicular. They are given two pairs of opposite edges are perpendicular, right? These two are opposite edges only, right? So that is, let the two pairs be, that is, so first pair is OA is perpendicular to BC. This is the first pair. And what about second pair? Second pair is OB is perpendicular to AC, right? Second pair is OB is perpendicular to AC. OB is perpendicular to AC. So they are given that two pairs of opposite edges are perpendicular. We need to prove third pair is also perpendicular. So that means we need to prove this is also perpendicular. That is, this is a third pair, right? So we need to prove OC is perpendicular to AB. Right? So what we need to prove? We need to prove OC is perpendicular to AB. This is what we need to prove. So if two pairs of opposite are perpendicular, then third pair is also perpendicular, right? So what we will do is we will prove this in terms of direction ratio, not in terms of direction cosine. We know that. So we know that what is the direction cosine of direction cosine of line joining two point, right? We know this. We know that direction cosine of line joining two point x1 y1 z1 x2 y2 z2. Let us call this as A, call this as B, right? Now what is the direction cosine of line joining two point? It is nothing but x2 minus x1 divided by length of AB, y2 minus y1 divided by length of AB, z2 minus z1 divided by length of AB. This is the direction cosine. Now what is direction ratio of line joining two point? So it is nothing but you don't need to normalize. So we will have x2 minus x1, y2 minus y1 divided by z2 minus z1. You don't need to normalize. That's it, right? So we know these two ideas, right? Now what I'm going to do is I'm going to find everything in terms of dr, because we need to prove only, right? In order to prove two lines are perpendicular, you can either prove L1 L2 plus M1 M plus M1 M2 plus N1 N2 is 0 in terms of DC. In terms of dr, we can prove A1 A2 plus B1 B2 plus C1 C2 is 0, right? So I'm going to find direction ratio. I'm going to prove everything in terms of direction ratio. Why? Because if I prove this, we need to find magnitude also. It will take time, right? We need to prove it is perpendicular. We can either prove in terms of DC or in terms of dr also. If I prove in DC means we have to find this denominator term. This is time consuming. So we will prove this in terms of dr, right? Okay. Now OA is perpendicular to BC, right? We have OA is perpendicular to BC. Now what is direction ratio of OA? It is nothing but x2 minus x1, y2 minus y1, z2 minus z1. So what is O? O is origin. A is x1, y1, z1. Now what is direction ratio of OA? It is x1, y1, z1, right? x1 minus 0, y1 minus 0, z1 minus 0. Now what about direction ratio of BC? So B is x2, y2, z2. C is x3, y3, z3, right? Okay. Now what is direction ratio of this? x3 minus x2, y3 minus y2, z3 minus z2. Now these two are perpendicular. Now since OA is perpendicular to BC, A1 A2 B1 B2 plus C1 C2 is 0. So we have x1 into x3 minus x2 plus y1 into y3 minus y2 plus z1 into z3 minus z2 is 0, right? All this as equation number 1. Now similarly we have OB is perpendicular to AC. Similarly we have OB is perpendicular to AC. So what is direction ratio of OB? So O is origin, B is x2, y2, z2. So this direction ratio is x2 minus 0, y2 minus 0, z2 minus 0. Now what about direction ratio of AC? So A is x1, y1, z1. C is x3, y3, z3. So this direction ratio is x3 minus x1, y3 minus y1, z3 minus z1. So since they are perpendicular, now since OB is perpendicular to AC, this implies A1, A2, B1, B2 plus C1, C2 is 0. So x2 into x3 minus x1, y2 into y3 minus y1 plus z2 into z3 minus z1 is 0. All this has equation number 2. Now we need to prove OC is perpendicular to AB. What we need to prove? OC is perpendicular to AB. That is, we need to prove now what is direction ratio of OC, what is direction ratio of AB. So OC direction ratio will be x3, y3, z3. Direction ratio of AB will be B minus A. So x2 minus x1, y2 minus y1, z2 minus z1. So we need to prove they are perpendicular. That is, we need to prove x3 into x2 minus x1 plus y3 into y2 minus y1, z3 into z2 minus z1 is 0. This is what we need to prove. We need to prove this. Okay, so we have 1 and 2. So I'm just going to add 1 and 2. I'm just going to add 1 and 2. So we need to prove this is equal to 0. So already we have 1 and 2. So I'm just going to add 1 plus 2. Just going to add 1 plus 2. So 1 plus 2. So what is 1? 1 is x1, x3 minus x2, x1, x3 minus x2 plus y1, y3 minus y2 plus z1, z3 minus z2 plus 2, x1, x3 minus x2, y1, y3, yes. And what is z2? x3, x2 minus x1, x3, x2 minus x1, y3, y2 minus y1, z3, z2 minus z1, right? I'm just going to add 1 plus 2. So we have equal to 0, right? Now we need to prove this. Okay, x3, x2 minus x1. Okay, let us multiply all this. x1, x3 minus, sorry, here we have x2, sorry, this is 2, right? x2, x3 minus x1, sorry. So 2 is x2, x3 minus x1. Okay, so we'll multiply all this. So we have x1, x3 minus x1, x2, y1, y3 minus y1, y2, z1, z3 minus z1, z2. And here we have x2, x3 minus x1, x2 plus y2, y3 minus y1, y2, z2, z3 minus z1, z2 is equal to 0. x3, x2 minus x1. So x1, x3 minus x1, x2, y1, y3, y x3, x2, common, take by 3 common. Is there any mistake I have made? OC is there any mistake I have made? Need to prove that this is OC is perpendicular to AB. Is there any mistake I have made? We have x1. Just a minute. We need to prove OC is perpendicular to AB, right? X1, x3 minus x2, y1, y3 minus y2, z1, z3 minus z2. X2, here I have made mistake. Just go through this. Here the terms are not cancelling, right? Instead of adding, can we subtract this? Instead of adding, can we subtract this? Instead of adding, can we subtract this? So we will have this will be minus, this will be minus, this will be minus. So this will be minus, a plus. Will be minus, will be plus, will be minus, plus. Yes, we have got the answer. Let us take this x3 outside here. X1 minus x2. And if I take y3 outside here, y1 minus y2. And if I take z3 outside, we will have z1 minus z2 is equal to 0. This is what we need to prove, right? x3, x2 minus x1. Okay, if you take minus outside and take that to that side, right? You just take minus outside, minus outside, minus outside. It will be x2 minus x1, y2 minus y1, z2 minus x1. Take minus throughout and take that to that side. So it will be same as x3, x2 minus x1, y3, y2 minus y1, z3, z2 minus z1 is 0. So we have minus outside common here. So take that to that side, right? So therefore, we have proved that they are perpendicular. Okay. So this implies OC is perpendicular to AB. So you only subtract this. Okay. So therefore, if two pairs of opposite edges are perpendicular, then prove that the third pair is also perpendicular. Very important question and easy question also. Okay. So move on to third question, 13th problem. If a pair of opposite edges of tetrahedron are perpendicular, if a pair, so here they are only one pair of opposite edges are perpendicular, then show that the distance between the middle point of the other two pairs of opposite edges are equal. So again, very easy problem. So we have a tetrahedron. This is our A, this is our B, this is our C. This is our origin. If a pair of, that is one of a pair of opposite edges are perpendicular. So we have one of the pair. I'm taking one of the pair to be OA, BC, right? So we have let one of the pair be let so we have a tetrahedron. Let this point be A, let this point be B, let this point be C. So let one pair be OA is perpendicular to BC, right? If one of a pair of opposite edges are perpendicular, so let this be one pair. The previous problem, two pairs are perpendicular means third pair is also perpendicular. So here one pair is perpendicular. Then prove that distance between middle point of other two pair. So what are the other two pair? OBAC is one pair, OCAB is one pair. So the other two pairs are, so OBAC is other pair. So middle point of OB, middle point of AC, right? Let us call this as M1, call this as M2. So this is we have three pairs. One pair is OABC. Other two pair is OBAC and OCAB. So the other two pairs midpoint B, let this point be M1, M2, and this pair is OCAB. Let this be M3, M4. OC midpoint is M3, AB midpoint is M4. Right? Show that the distance between middle point of other two pairs of opposite edges are equal. So we need to show M1, M2. We need to show the distance between M1, M2 is same as M3, M4. This is what we need to prove. Is it clear? Show that the distance between middle point of other two pairs of opposite edges. So other two pairs of opposite edges are OBAC. So that middle point of this OBAC is M1, M2, and other edges is other opposite pair is OCAB. So M3, M4. So we need to show the distance M1, M2 is same as M3, M4. This is what we need to show, right? So the first problem, the previous problem is if two pairs of opposite edges are perpendicular, third pair is also perpendicular. So here if one pair is perpendicular, then other two pairs you just form a middle points, connect this, that length will be equal. M1, M2 is same as M3, M4, right? Okay. See, you just have to write on the story. Let M1 and M2 be the middle point of other pair, which is OB is perpendicular to AC, and M3, M4 be the middle point of OC is perpendicular to AB. That is the next third pair, right? Just have to write it down. I'm not writing that. Let M1, M2 be midpoint of this first pair is already perpendicular of second pair. What is second pair? OB is perpendicular to AC, and let M3, M4 be the midpoint, the third pair. OC is perpendicular to AB. Now we need to show M1, M2 is same as M3, M4. Now very simple again. What is M1? M1 is midpoint of OB. Use midpoint formula. So already we know OA is perpendicular to BC. Now since OA is perpendicular to BC, now what is direction ratio of OA? So it is nothing but x1, y1, z1, right? O is origin, A is x1, y1, z1, x1 minus 0, y1 minus 0, z1 minus 0. Now what is direction ratio of BC? BC. So B is x2, y2, z2. This x3, y3, z3. This x1, y1, z1. So what is direction ratio? BC, x3 minus x2, x3 minus x2, y3 minus y2 plus z3 minus z2 is equal to 0, and they are perpendicular. This implies x1 into x3 minus x2, y1 into y3 minus y2, z1 into z3 minus z2 is 0, right? Let us call this as equation number 1. Now we need to show m1, m2 is same as m3, m4. Now what is m1? M1 is the midpoint of OB, point of OB. So M1 is nothing but what is midpoint formula? So OB, so x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. O is origin. So we have x2, what is the midpoint? x2 by 2, y2 by 2, z2 by 2. See, O is 0, 0, 0. B is x2, y2, z2. Midpoint will be 0 plus x1 by 2, 0 plus y1 by 0 plus y2 by 2, 0 plus z2 by 2. And again, what is M2? M2 is midpoint of AC. Midpoint of AC is x1 plus x3 by 2, y1 plus y3 by 2, z1 plus z3 by 2. Similarly, M3, M4. So M3 is midpoint of M3 is midpoint of OC. Midpoint of OC, which is x3 by 2, y3 by 2, z3 by 2, and M4 is midpoint of M4 is midpoint of AB, which is nothing but x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. So all these are very simple problems, right? You just work it out for 1 or 2 times, then all this will be very easy to follow. Okay. Now you need to prove M1, M2, M3, M4. Now find distance between M1, M2. Find distance between M3 and M4. Now what is distance between M1 and M2? Square root of x2 minus x1 whole square. Now I'm just finding square of this. So I don't need to put square root. Distance between 2 points is root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. I'm just squaring here so that we don't need to put root. Just put x2 minus x. Just put x1 plus x3 minus x2 by 2 whole square, y1 plus y3 minus y2 by 2 whole square. See, x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. We have square root, but I'm squaring this side. z1 plus z3 minus z2 by 2 whole square. Right? This is our m1, m2 whole square. Now, similarly, what about m3, m4 whole square? So it will be x1 plus x2 minus x3 by 2 whole square, y1 plus y2 minus y3 by 2 whole square, z1 plus z2 minus z3 by 2 whole square. Right? Now just make use of a plus b plus c whole square formula, and you will get all the terms to be cancelled. And if you have this term, you can put this term to be 0. Right? Whenever you see, you just have to you need to, what I will prove is, we will prove that m1 m2 whole square minus m3 m4 whole square is, you show it is equal to 0. You just subtract this, that is, you just subtract these two, and you show that is equal to 0. That is same as proving m1 m2 is same as m3 m4, right? So you just subtract this. So just make use of the formula a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So you will have 6 terms. You will apply formula for all 6 terms, and you see some of them will get cancelled, and you will remain at this stage. You can put this term to be equal to 0, because we know OA is perpendicular to BC, right? So use one, you will have this term to be equal to 0. So this implies m1 m2 is equal to m3 m4. This is what we need to prove. See, I'm not doing this step. You just have to see, here you have 3 terms, minus minus minus. So you need to apply for 6 terms, a plus b plus c whole square formula. Many terms will get cancelled. You will have this term alone, and this term is also equal to 0 by 1. So therefore m1 m2 is same as m3 m4. This is what we need to prove. So therefore what it says is, if one pair of opposite edges of a tetrahedron are perpendicular, now you find the midpoint of the other two pairs. That midpoint will be same. M1, M2 is same as, the distance from M1 to M2 is same as distance from M3 to M4. Is it clear? Still 2 more problems left. So we move on to 14th problem. Again, these are very easy problem, right? Again, I'm not going to do this. Just going to give only hint. In a tetrahedron OABC, if OA square plus BC square is same as OB square plus CA square is same as OC square plus AB square, then show that its pairs of opposite edges are at right angles. Very easy. If this happens, then all 3 are right angles. Right? The very first, that is in the previous problem, we proved that if 2 pairs are right angles, then third pair is also right angle, perpendicular, right? Now here, these 3 will be perpendicular if this happens. That is all we need to prove. So we have a tetrahedron. We have A, we have B, we have C, and we have origin. So these opposite edges need not be perpendicular always. But if this happens, then opposite edges will be perpendicular. So that is, we need to prove OA is perpendicular to BC, then we need to prove three things. We need to prove OA is perpendicular to BC, and we need to prove OB is perpendicular to AC, second thing. And the third thing we need to prove OC is perpendicular to AB, right? So what we need to prove is, we need to prove OA is perpendicular to BC. We need to prove three things. So OA is perpendicular to BC. That means what? What is direction cosine of OA? This is x1, y1, z1, x2, y2, z2, x3, y3, z3. Now, what is direction cosine? Sorry, direction ratio. What is direction ratio of OA? It is x1, y1, z1. What is direction ratio of BC? It is x3 minus x2, y3 minus y2, z3 minus z2. And since they are perpendicular, direction ratio are direction ratio will satisfy this condition, right? A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So OA direction ratio is x1, y1, z1. DC direction ratio is x3 minus x2. So we will have, so we need to prove x1, x3 minus x2 plus y1, y3 minus y2, z1, z3 minus z2 is equal to 0. So we need to prove three things. This is the first thing we need to prove. And second thing we need to prove OB is perpendicular to AC. Now what is direction ratio of OB? It is x2, y2, z2. This is 0, 0, 0. And what is direction ratio of AC? It is x3 minus x1. So we have x2, x3 minus x1, y2, y3 minus y1, z2, z3 minus z1 is 0. This is the second thing we need to prove. And the third thing we need to prove, OC is perpendicular to AB. So these see, very easy, right? I think you're able to follow, right? I'm just finding dr of OA and BC and using the condition, that perpendicular condition, A1, A2 plus B1, B2 plus C1, C2. So dr is nothing but you can just subtract the coordinates. For DC, you need to divide by its magnitude. Okay. So OC perpendicular to AB. So C is x3, x2 minus x1, y3, y2 minus y1, z3, z2 minus z1. These are the three things we need to prove. So if this happens, we need to prove ABC. So very easy. So first equate this and this. You will be proved with A or B or C, and equate this and this. You will be proved with A or B or C, and equate this and this. You will get proved with the other thing. So first equate OA square plus BC square. So we have OA square plus BC square is equal to OB square plus CA square, right? I'm just equating the first two terms. So you simplify this, you will get proved with any one of A or B or C, right? A or B or C. Now what is OA? Distance from O to A, squaring. You don't need to put square root. So it is root of x1 minus 0 whole square, y1 minus 0 whole square, z1 minus 0 whole square. But you don't need to put square root because we have square here. So it is nothing but x1 square plus y1 square plus z1 square. Now what is distance from B to C? Distance from B to C, x3 minus x2 whole square, y3 minus y2 whole square. Usually we have square root, but since we have square here, I'm not putting that. This is equal to OB square, distance from O to B. So B is x2, y2, z2. So it will be x2 square plus y2 square plus z2 square. Distance from C to A. So C is x3, y3, z3. A is x1, y1, z1. So it will be x1 minus x3 whole square y1 minus y3 whole square, z1 minus z3 whole square. Now you need to simplify this. You need to bring any one of this pattern, A or B or C. Okay. See, you just have to simplify this. So we have x1 square plus y1 square plus z1 square, a square plus b square minus 2ab, right? Again a square plus b square minus 2ab, a square plus b square minus 2ab. Again there you will have this is equal to x2 square, y2 square, z2 square, a square plus b square minus 2ab, a square plus b square minus 2ab, a square plus b square minus 2ab. See, x1 square, y1 square, z1 square, x1 square, y1 square, z1 square, x2 square, y2 square, z2 square, x2 square, y2 square, z2 square, x3 square, y3 square, z3 square, x3 square, y3 square, z3 square, right? Okay. Now, see, here minus minus minus, here also minus minus minus. So all will get cancelled, right? This minus minus, this minus minus, this minus minus will get cancelled. If I take minus outside, here if I take x3 outside, so we will have 2 into, if I take 2 x3, or you can also cancel 2 also, right? Also cancel this 2, 2, 2, take 2 outside and cancel this 2, 2, 2. Now we will have, here you have, if I take x3 outside, we will have x2 minus x1, right? Because it is equal to. So if I take x3 outside, bring this term that side, x2 minus x1. And if I take y3 outside, we have y2 minus y1. And if I take z3 outside, we will have z2 minus z1 is equal to 0, which proves what? Which proves 3, which proves C. Which proves C. Now similarly, you take the second condition, that OB square plus CA square is equal to OC square plus AB square. So make use of this. You will be proved with A or B. And similarly, the third OC square plus AB square is equal to OA square plus BC square. So similarly, you prove this. This will prove B and C, or A and B. This will prove A and B. So very simple. You need to prove these three things. If this happens, so consider 1 and 2 distance formula you need to apply. You need to prove this. Here, if you do this, it proves C. And similarly, you do this and this and that and this, it will be proved A or B. Is it clear? Yes, we'll move on to last problem in today's session. Yes, no doubt, right, as of now. So we'll be doing the last problem in DC and DR. After that, we'll be moving on to planes in the next class. Find the direction cosine and direction ratio of the internal angle bisector and external angle bisector, right? Let us have a 2-minute break now. After that, we will continue this. So we'll do the last problem and then we'll wind up this. Find the direction cosine and direction ratio of internal angle bisector and external angle bisector. Right? So first we will find dr and dc for internal angle bisector. So let us take an origin. We have two lines. This is our L1, this is our L2. Right? Now, so this makes an angle some theta, right? Now we need to find internal angle bisector, a line that bisects the angle. So this is our internal angle bisector. You can see this bisects the angle. Right? If it is theta means this is theta by 2, theta by 2. Let's call this as M. Right? Let's call this point to be A, call this point to be B. So we need to find dr here. First here OM is the OM is the internal bisector. OM is the internal bisector. So we need to find the dr and dc of OM. We need to find the dr and dc of OM. It's very easy. So let L1 let L let let direction cosine of the first line be L comma M comma N, and direction cosine of second line be L2 M2 N2. So you assume that the length of OA and the length of OB is 1, right? So even if not 1, you just cut it off, right? So if OA is very large, this is line only, right? So you just cut it off this line such that the length of OA and OB is 1, right? So assume that the length of OA and OB is 1, right? If not, you can cut it off to 1. Now since OA and OB is 1, and this has direction cosine L comma M comma N, what can you say about the coordinate of A? What can you say about the coordinate of, what can you say about A and B? What can you say about the coordinate of A and B? So clearly the coordinate of A is also L1 M1 N1, and B is L2 M2 N2. Why? Because we know this is a unit vector, right? Because we know this is a unit vector. Li plus Mj plus Nk is a unit vector. That means this coordinate will be from O to L comma M comma N. See, this vector is Li plus Mj plus Nk. That means this coordinate is L comma M comma N. We already did this, right? And similarly, this is a unit vector. So therefore, this is also L2 M2 N2 is the coordinate of B. Because 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 OA and OB are unit vectors. Now what can I say about M? M is the midpoint of AB. M is the midpoint of AB. So therefore, your M is L1 plus L2 by 2, M1 plus M2 by 2, N1 plus N2 by 2. This is the coordinate of M. So you know both the coordinates. You know both the coordinates. Right? Now you find dr and dc. What is dr? It's nothing but x2 minus x1, y2 minus y1, z2 minus z1. Right? So what is dr of OM? Direction ratio of OM. Right? So it is nothing but L1 plus L2 minus 0 by 2. So you can omit this 2 to 2 because it is proportionals only, right? So it is nothing but L1 plus L2, M1 plus M2, comma N1 plus N2. This is the direction ratio of OM. So we will have this minus this, this minus this, this minus this. Since 2 is proportional, for direction ratio we don't need proportionals, right? This is a direction ratio. So we have found direction ratio of internal angle bisector. So what is the direction ratio of internal angle bisector? L1 plus L2 by 2, M1 plus M2 by 2, N1 plus N2 by 2. Now how to find direction cosine? Very easy. Call this as A, call this as B, call this as C. What about direction cosine? So direction cosine of OM will be, you have to normalize this. So A divided by root of A square plus B square plus C square, B divided by root of A square plus B square plus C square, C divided by root of A square plus B square plus C square, and the A is L1 L2, B is M1 M2, C is N1 N2. Now we will find this term. A square plus B square plus C square. So it is L1 plus L2 whole square, M1 plus M2 whole square, N1 plus N2 whole square. So L1 square plus L2 square plus 2 times L1 L2, M1 square plus M2 square plus 2 times M1 M2, plus N1 square plus N2 square plus 2 times N1 N2. So L1 square plus M1 square plus N1 square will be 1 because L1, M1, N1 is the direction cosine of first line. So this will be 1. And again L2 square plus M2 square plus N2 square will also be equal to 1. So we will have So we will have 1 plus 1. So these three terms will be 1, these three terms will be 1. And if I take 2 outside, we have L1, L2 plus M1, M2 plus N1, N2. Remember, this is not perpendicular. If it is perpendicular means you can put 0. So here it is not perpendicular. It is nothing but theta, right? Angle between OA and OB. So which is nothing but cos theta. So we have 2 plus 2 cos theta, right? Because cos theta is L1 L2 plus M1 N2 plus N1 N2, right? If it is perpendicular means you can put 0, but here it is not perpendicular. Now what about the value of root of a square plus b square plus c square? This root of 2 plus 2 cos theta. So if I take 2 outside, we will have 1 plus cos theta. So 1 plus cos theta is 2 cos square theta by 2. 2 cos square theta by 2. Now this is nothing but 2 cos theta by 2. Right. So 2 cos theta by 2 is the value of root of a square plus b square plus c square. So therefore, direction cosine of internal angle bisector is given by a. A is L1 L2. L1 plus L2 divided by 2 cos theta by 2. M1 plus M2 divided by 2 cos theta by 2. N1 plus N2 divided by 2 cos theta by 2. So this is the direction ratio of internal angle bisector. This is the direction cosine of internal angle bisector. So similarly, we need to find direction ratio and direction cosine of external angle bisector. External angle bisector, right? This is for internal angle bisector. Now we'll similarly do for external angle bisector. Or external angle bisector. Again, consider the same diagram, but here it has to be externally bisecting. So we have this is our line L1, this is our line L2. Same assumptions, right? That length of OA and OB is 1. See, this is your internal angle bisector. Now we need to find external angle bisector. So this is our external angle bisector. So you just draw a line that is perpendicular to this. So this is your internal angle external angle bisector. Sorry. So you need to find the direction ratio and the direction cosine of this line. OM is your internal angle bisector and ON is your external angle bisector. Right? Now what you can do is you just how to see what we need to do is you just need to you just multiply this line with minus. So you will have something like this. This is nothing but minus b, right? I think the diagram is cross, right? Right, we'll write this of scale. See, this is our external angle bisector, right? So you can see this is bisecting off. So we need to find dr and dc of external angle bisector. So again, very simple. Now clearly, again, you just write the same story. OA and OB length is 1. So since this line has direction cosine L1, M1, N1, this line has L2, M2, N2. So coordinate of A is What about the coordinate of A? Same story. Coordinate of A is L1, M1, N1, and coordinate of B is L2, M2, N2. Okay, let us call this to be minus B. Let us call this as some P, right? Now what about P? So P is nothing but minus L2 minus M2 minus N2. So we need to find, okay, we need to find we need to find ON, right? ON, yes. Sorry, what is your internal angle bisector? Just a minute. ON, ON, oh, yes, correct only. We need to find ON, right? Yes, L, this is L comma M comma N. This is minus L comma minus M comma minus N, right? Sorry, this is L1, M1, N1, and this is minus L2, M2, N2, because A is L1, M1, N1, B is L2, M2, N2, L1, M1, N1. This is minus L2, minus M2, minus N2. Now we need to find N. What is N? N is the midpoint of AB, right? Call this as N. Call this as N. So N is midpoint. So it is nothing but L1 minus L2 by 2, M1 minus M2 by 2, N1 minus N2 by 2. Now what about direction ratio? What about direction ratio of ON? So we need to find DR and DC of this line, right? We need to find DR and DC. We know the coordinate of N, we know the coordinate of O. So therefore, what is DR, direction ratio of external angle bisector? So it is nothing but subtract the coordinate. I'm just not writing 2, 2, 2. So it will be L1 minus L2, M1 minus M2, N1 minus N2. Since it's proportional only, right? This is 0, 0, 0. This point is L1 minus L2, M1 minus M2, N1 minus N2. So direction ratio of this line is 0 minus L1 minus L2, 0 minus M1 minus M2, right? All are same only. So this is our direction ratio of this line. Let's call this as A, B, C. Now what about direction cosine of ON? So it is A divided by root of A square plus B square plus C square. B divided by root of A square plus B square plus C square. C divided by root of A square plus B square plus C square. Now find the value of A square plus B square plus C square. So what is A square plus B square plus C square? So it is L1 minus L2 whole square, M1 minus M2 whole square, N1 minus N2 whole square, L1 square, L2 square minus 2 L1 L2, M1 square, M2 square minus 2 M1 M2, N1 square, N2 square minus 2 times N1 N2. So again L1 square plus M1 square plus N1 square is 1. L2 square plus M2 square plus N2 square is 1. If I take 2 outside, we will have L1 L2 plus M1 M2 plus N1 N2 minus 2 outside. It is 2 minus 2 cos theta. 2 minus 2 cos theta. So here we have 2 plus 2 cos theta. Here we have 2 minus cos theta. So if I take 2 outside, we will have 1 minus cos theta. So 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. So we will have this to be 4 sin square theta by 2. The value of square root of, just a minute, I think battery is off. Just a minute. Hello, hello, hello. Is it audible now? Yes, sorry, sorry, sorry. I don't know how the mic is turned off. Is it audible now, right? I haven't seen your comments also. Okay. So uh, what we did here is we have left it this stage, right? So this is 2 sine theta by 2. So therefore, the direction cosine of external angle bisector. Hello, hello, hello. Yes, I think it is. It will be audible now. Sorry, actually there is charge is no charge in this, right? No problem. I think it will be audible now. So I'll just I think we have finished our session today. And just give me 1 minute. I'll just wind off what we have seen, right? I think you have stopped at this stage, right? So here we have 2 sine theta by 2 is the value of root of a square plus b square plus c square. So just substitute back here. So L1 minus L2, b is m1 minus n2, c is n1 minus n2. Root of a square plus b square c square value is 2 sine theta by 2, 2 sine theta by 2 sine theta by 2. The conclusion is direction ratio of internal angle bisector is L1 plus L2, M1 plus N2, N1 plus N2, and direction cosine of internal angle bisector is L1 plus L2 by 2 cos theta by 2, M1 plus M2 by 2 cos theta by 2, N1 plus N2 by 2 cos theta by 2. And direction ratio of external angle bisector is L1 minus L2, M1 minus M2, N1 minus N2, and direction cosine of external angle bisector is this. The only difference is There we have L1 plus L2, M1 plus M2, N1 plus L2 for direction ratio. Here we have minus here. And for direction cosine, there we have plus 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 and cos theta by 2, cos theta by cos theta by 2. But here you have sin theta by 2 and minus minus minus. Right. So we have completed the topic of direction cosine and direction ratio. We have solved 15 problems. From these 15 problems, there is no previous year's questions from this topic in IAS. But in IFOS, we have 4 previous year's questions from this topic that we have already solved. Right? What are those 4 questions? They are, in the very first class, we have solved one IFOS question. They will give direction cosine of two lines. They are connected by some relation. Prove that they are at right angles. That we have already solved. And in the previous class, we have solved two IFOS questions. Prove that it will be parallel if this condition holds and perpendicular if this condition holds. We have solved two problems like that, right? We have solved two problems like that. And in this class, we have solved one more problem, PYC question. That is that the cos square alpha plus cos square beta plus cos square gamma plus cos square delta, that is equal to 4 by 3. We have solved one problem, right? That is also an IFOS question. So there are 4 IFOS questions from this topic which we already solved. And you can if they are asking a question from DR and DC, surely it will be from these 15 questions only. And I will send some practice questions also in the Telegram group, maybe next 2 or 3 days. We will finish this topic and then you will also write one test in this so that this topic will be completed. The next class will be starting planes, right? Planes will go for 4 classes. So DR and DC we are completed in 3 classes. Planes will go for 4 lectures. 4 lectures will go for planes, and then we'll move on to all other topics, right? So you can check it out in Google, Nagaprakash. Then you let me know, right? Um, N is the midpoint of AB. Yes, N is the midpoint of N is the midpoint of AB. So all are the properties of internal and external angle bisector. All are properties of internal external angle bisector only. N will always be midpoint only. Right? See, because this divides an angle equally, right? That means this has to be midpoint for this, right? So these are the properties of internal external angle bisector. So the next class we will be starting planes, right? So thank you. All the best. Oh, okay, okay. So N is the midpoint of A, P. N is the midpoint of A, B dash or A, P. Right? N is the midpoint of this. This minus B. Minus B is P. Assuming this to be P. Right? Okay, okay. Sorry. Okay, thank you. All the best. This video will all automatically uploaded in YouTube, right? Automatically it will be uploaded in YouTube. Just go to our channel and go to live classes. You will be seeing all the recordings.